It's a Cybrink pod. Ooh, did you hear that? Maybe I need some voice gene therapy to help me grow up and fit into my 31-year-old body. Let's try that again. It's a Cybrink podcast. My name is David J. Dickman. You can follow us on Twitter. It's at Cybrink Media. And I'm at David J. Dickman. And if you could hit that subscribe button for us, we got a lot of awesome interviews and ones we've done in the past with Avi Roy, which, by the way, Liz Parrish, Avi Roy is on your website.
Yeah, actually, Avi Roy is one of our scientific advisors. He's on our advisory board. And so, yeah, he's part of the BioViva mission in a sense.
So with us today also is Dr. Avi Roy. Am I saying that right?
Yes, you are. You're saying that right. But I mean, you can just call me Avi. You don't have to use the honorifics.
Okay. I accidentally just said Aubrey de Grey instead of Dr. Aubrey de Grey, and the internet got mad at me. And not that I care, but now I'm just hyper conscious of it. So I have known Aubrey for a very long time. He is a great mentor to me, and I don't think Aubrey cares one bit about the honorifics. He wants to get the job done, just like Liz and myself. Yeah. It seems like everyone we work with have thrown off their honorary titles, and it's really what you can achieve in your lifetime. But I still like the titles. I think it's pretty cool. I'd like to have a few. It's so crazy because you guys are working on something that's kind of a team effort. And I don't know that much about the science field. I was kind of starved of some science education growing up. I went to a religious school that really didn't touch on it all that much. And so I'm really fascinated by it. But in the scientific community, it's kind of competitive in peer-reviewed journals and just trying to get these headlines and get some money in and all this stuff. But really, when it comes down to solving aging, people are working together. That's exciting. Yeah, it's really a group effect. And so when we look at mitigating complex disease, which is BioViva's mission, it has a focus on biological aging because that's the biggest killer on the planet. We definitely need to work together. So if we were just a company that was making one product in the lab to affect one of the hallmarks of aging, we might then go it alone and think that was great. But actually what BioViva is a clinical platform to bring together biology companies, companies who have great biotech, and get them into humans and find the combination that actually works. I think that we're pretty skeptical that it would be one therapy to a cure for anything complex. So we need to get all of these therapies together. We need to start trials in humans, start work in humans, work towards consensual use of therapies, and see what combination of therapies, not just one company's technology, but what combination of companies' technology will actually affect biological aging. And so let's go biologically as best as possible, and we're going to jump around, kind of hopscotch around. But Avi, can you just talk about your what's on your resume, basically? Okay, I guess I could. I didn't know that I was coming in for an interview, but that's fine. Well, I'm a biomedical scientist. I have background in multiple disciplines, including computer science and biochemistry. But during my PhD, my PhD work was done in human skin cells and trying to rejuvenate them using interesting molecules. So ultimately, we were looking at mitochondria and see if the powerhouse of the cell, if we can rejuvenate those, can we actually bring back all of the health and well-being of a skin cell? And if we could do that in a skin cell, could we do that in other cells as well? So that was the bulk of my work. After my PhD, even while I was doing my PhD, Liz and I were friends before Liz launched BioViva, and we had been working in the field trying to mitigate aging using public dissemination of science. But while I was finishing up my PhD, Liz started BioViva, and I had been working with her ever since. And I have since then advised jointly, along with Liz, governments in various places as to how to do regulation so that we can have these treatments available to patients as quickly as possible. That was, I think, the reason why I have put academia a little bit on the background in my case.
and move towards where Liz is, which is in implementation and getting to patients directly, because I want these improvements for people's health available today or tomorrow rather than 40 years from now. So the pace of change is moving rather rapidly, and that's why I have moved from academia more to implementation side. So the two main things that I do now is work with BioViva to get treatments for patients out as quickly as possible and as effectively as possible, and advise governments and investment banks to invest in the right kind of project and build the right kind of infrastructure. So not just our company, as Liz has been mentioning, but other companies who are trying to do the similar things can succeed.
Yeah, and it's an exciting time too right now, because the science is just exploding with things like CRISPR and gene editing, and I guess under that realm is transhumanism, biohacking. They're all kind of synonymous yet different in their own sect. But it's super exciting time. And this, Liz, this isn't something you've done for a long time. This is something you started. You're an entrepreneur. So what was your background like? Where did you come from, and how did you land in this exciting field in the exact, like, almost perfect time to be in it?
Yeah, well, actually, it was a series of unfortunate events that led me into this field. Luckily, again, here in my family, we have software companies, and so I understood the idea of programming. I had some basic biology background. I had not finished my degree in biology, but I had been taking biology. I had stayed in touch. I was working for a nonprofit to educate the people about the use of stem cells, that stem cells were in fact a great regenerative medicine that was not just on the horizon, but was potential reality, and that it had gotten a pretty bad blow when embryonic stem cells were banned in the U.S. The information that had disseminated to most of the population that most of the use of stem cells were in fact embryonic stem cells, and that was not the case. And so I just happened to be so lucky to always stay in touch with the field, and then got to work with this nonprofit about educating people about the use of stem cells. And then my son was diagnosed with diabetes type 1. And it was pretty shocking. I didn't know anything about the disease, no family history. It's a complex disease. It's an autoimmune disease, and landed in the hospital. And so when I started asking around at the hospital, well, what do you have for biobanking his pancreas cells, and what do you have in stem cells to maybe regenerate his pancreas and things like this, they basically said there were no new options, and that diabetes was a treatable disease. And therefore, we should go with the option that was offered, and that I should look around the hospital and see that my son was actually considered very lucky. There were a lot of kids there that were dying. And so I did. We were there for many days. You have to stay in the hospital for many days. You need to learn how to treat your child's disease before you come home. Again, diabetes type 1 cannot be managed with diet and exercise. It's insulin dependent. Every meal, there's insulin injections and checking blood, and you need to know what all of that means. So you don't get to just go home. And so I spent a few days there, and I looked in different wards, and we spent time where kids get together to play, and I learned a lot about what was happening in the reality of people's day-to-day lives, and that was that their kids were dying. So yeah, I got pretty charged up, and I came home and expanded on what I already knew and started looking for conferences, scientists that I could meet that might know more about what was happening with complex disease. I was always interested in genetics and thought that this might be the place where we solve the problems that we're looking towards stem cells to solve to begin with. So I went to a few conferences, and one of the conferences that I happened to go to was Aubrey de Grey's SENS conference in Cambridge, United Kingdom. I got on a plane and took a few trains, and, English-speaking country, easy enough. And I said, what is longevity? And every speaker who got off the stage, I just grilled them. What does this mean? What can your product do? How does this affect kids? And I found out that essentially the way that our bodies work, some of us die young and some of us die old, but it all comes down to our genes. And this, I felt, could be a revolution in how we work together and see it. So my background was probably the perfect background. We had run our own companies, so I had the entrepreneurial spirit. I had 2 kids, so I certainly had the managerial spirit. And then I'm a mother, and that means I absolutely am not going to stop. And I had just enough science to be dangerous and to actually know that I needed to bring the team together that had more experience than I do, that had the background that I needed to get this done. And so that's a very long answer to a simple question.
I love long answers. I'm a big fan of them. Just get a lot of information out of it. Well, wow. Thank you for sharing that story, because I'm sure you've said it a lot because you've done a lot of media, but still, it's got to, you feel those feelings that you've had when you were in that hospital when that was happening, right? Still to this day. It's a whole driving force behind it, right?
Yeah, I've actually only described that a couple of times, and this is probably one of the only times that I've done it without completely breaking down. It is. I just right now I just can't picture it. If I picture it, I go there, and it's, this isn't just like something that happened to me one day, and then my son got some insulin and got to come home. This is happening to people every day. And it is terrible to lose your grandparents, but losing a child is like, it's not even in the realm of what we think will happen in our lifetime. And so, these people my hats go off to them. They get up and they go on with their lives. And I suggest that they all start a biotech company.
Yeah, there's a distinction between type 1 and type 2 diabetes. Type 2 is typically adult onset. It can be brought on by diet or other lifestyle choices. Diabetes type 1 is something that you don't get a choice. It's something that's genetic. Is that correct?
Yeah, you don't get a choice. I think that the closest thing that we have to an answer right now is that what we think that it is that a virus goes around, and most of the population handles that virus well, a virus or a bacteria, but these kids get sick with it, and what happens is your immune system, you can think of it as it sort of builds these Lego blocks, and these Lego blocks go and they fit the germ that they're looking for, the thing that they're trying to eradicate in this case. And what happens is they build something that looks a little bit too close and fits a little bit too well with your cells, but Avi would probably give a better description than that. So essentially the immune system attacks your own body rather than just eradicating the problematic character in the system.
So to save, in the interest of saving time, I'm going to urge everyone that's viewing this to go back and listen to the Aubrey de Grey or Dr. Josiah Zahner. I did it again. Dr. Aubrey de Grey and Dr. Josiah Zahner, to go back and listen to the episodes on CRISPR and then find out what the Sense Foundation is doing. And there is a clear distinction here that the Sense Foundation is research. That is not at all what's going on at your company, that you're a CEO at, Liz, and then Avi, you are the CTO. You guys are in the application, not in the research. Is that correct?
Yeah, that's right. So we are going to expand into some amount of research, but we are designed to be pure application. So how do we get the most promising therapies to patients that need them now? And how do we eventually open these therapies up to consensual use? So, right now we're building the supercomputer and everybody wants one. Lots of people contact us and want to be part of it. But the idea is to get you a smartphone down the road, technology that is competent, proficient, and predictable. And this is what I foresee in the next 15 years, which I'm very excited about, is that right now we see a world that people don't know much about their biology. But I think in 15 years, we'll know a lot about our biology, and we'll start to think about the upgrades that we want. We'll start preparing for either affording them or our vacation to get them, or where we get them, right here in the U.S., maybe by that time. So I foresee a future where we know as much about our bodies as we know about the apps on our phone. We don't exactly have to know how they work. We just need to know how they make our lives easier, how they keep us from getting sick. In the future, how they make us stronger, faster, and smarter, maybe more perceptive in other ways. I think that people are going to get really excited about this technology. And of course, we want to be on the forefront, the very simple, basic forefront of eventually being able to offer the therapeutics in that way.
Since we were talking along the lines of diabetes type 1, you were patient 0 for gene editing. Is that correct? Is
gene therapy.
Sorry. So it's gene therapy, and then you did two different things. There's a myostatin inhibitor and then also a telomere length. I'm saying this wrong. Okay, I said length increaser. What's
that works.
So I want to touch on the myostatin inhibitor, because this is something that the bodybuilding community, not that I'm a bodybuilder, obviously, but the bodybuilding community is just fascinated by it, because if you type in myostatin inhibitor and you hit images on Google, you will see the most ripped cows, pit bulls, and then you'll see like some rat tendons. And then the rat tendons were the most exciting to me, because if you have some nice, thick, healthy tendons, man, you can prevent some injury. So it's pretty neat. I myself would sign up for some myostatin inhibitor gene therapy today. I'd fly out. I'd be all about it. But some people are like, man, you're crazy. I would never do it. What are the dangers, and tell me about the decision, the internal debate or struggle that you had going into eventually doing this gene therapy?
Okay, so when we talk about the myostatin inhibitor, I think some of the things that you see online are what are called myostatin knockouts. They are animals that have actually been developed that do not create myostatin. And for your listeners, let's make this really, really simple. Myostatin blocks your ability to gain muscle mass, or regulates it when you're young. You have myostatin when you're young, but you're in the grow and go phase, so you can build muscle. But then myostatin continues to do its job, and as you get older and it becomes more difficult to build muscle and you no longer have these super growth hormones going on, myostatin impedes the development of muscle. So it not only makes it harder to gain muscle, but if you don't work at it, by around the age of 33 to 35, you start to lose a certain percentage of muscle mass year by year. Okay, so that sounds really scary, and what that means is this leads to things like frailty. This leads to people falling down and breaking their hips. This leads to needing a house without stairs. Things that we see older people do. So the promise of a myostatin inhibitor, something that blocks myostatin and allows the muscles to grow again, has been a huge interest to the pharmaceutical industry and to drug development companies actually now in the last, I'd say, 15 years. So we see companies wanting to develop therapies like this, and we're very excited about the gene therapy. We're excited about maybe a one-time treatment to developing your muscle mass. So because we're not blocking all of myostatin, you still have some of it, your results from a gene therapy are determinant on how much you block the myostatin. So we're not going to block it like the blue cows or those greyhound dogs that you see that are so massively muscular. And many of the images that you actually see of people in the bodybuilding community, which I commend, I love everyone who does something to an extreme to check out our limits, but they are actually combining things. They're combining myostatin inhibitors with growth hormones, things that we don't have anymore that derive drives that massive development. So if you were to come to BioViva, so you're going to come over next week, we're signing you up, and you're going to get your myostatin inhibitor, you're not going to see incredible Hulk-like development of the muscles. We're not going to completely block your myostatin. We're going to give you a series of injections. And over the next 4 to 6 months, maximum at 1 year, you're going to develop more muscle mass and you're going to increase your strength. But again, it's going to be limited to the amount of therapy you take and the amount of time that you put into developing your muscles. So the things that we see that on the internet are not always indicative of the things that we see in a gene therapy. Now, could we create this massive hulking person with a gene therapy? We probably could, but I don't think we would want to do that. I think that creates physical limitations in itself, and as a company, we wouldn't want to do that. We would create healthy muscle mass to the extent that a person thought was something that worked within the realm of their life.
Yeah, and then also, and correct me if I'm wrong, Avi, but if you completely block the myostatins, then you can become hypoglycemic, you'd have low blood sugar, there's all sorts of problems that come up. So it's not necessarily a binary issue, it's more of a spectrum, and thus the delicate balance of anti-aging and the formula of it all.
Yeah, no, you're absolutely correct. I always say this thing, that there's no such thing as a good or a bad in biology. There is only moderations. So we have grown up with the term called good cholesterol and bad cholesterol. But if you completely remove LDL, which is considered the bad cholesterol, well, biochemistry doesn't function. Yeah. Similarly, what you're talking about, myostatin inhibition, and you pointed out certain specific things like hypoglycemia, well, those are just certain effects that we know of. So yeah, completely knocking something out, completely knocking something in, and this is what Liz was talking about with the Belgian blues. These are knockout animals. Yeah, they do have lots of problems. I mean, these cows were bred, but they weren't knocked out like we do rats and mice, mainly mice in the lab, and they have lots of problems. Their heart muscles grows a little too quickly. And they have lots of cardiac issues beyond the issues that you just talked about. Yeah, so absolutely. Biology is not very simple. The one thing that I also want to note is that you mentioned that Liz had gene editing, and then Liz corrected you as gene therapy. I always want the greater audience that is listening to think of gene therapy as a broader scope thing. So it's like, think of it as the superset, which consists within it upregulating or turning proteins or turning genes on. And now the new tool is where we can actually put cut and paste copies of genes that you didn't have before in. And other things that BioViva are planning to do is mRNA therapies. So these are things that will dim the light switch a little bit more. So where we are going in the future is from imprecise control, where we had the flick on-off switch, to a dimmable switch. And then ultimately, hopefully, that dimmable switch can be on an app on a phone. Don't take me literally, but I'm talking about things like optogenetics and so forth.
You're going to be all excited, dude. What the?
Yeah. So it's all about precision and control and getting the nuance right. Nature does it in a beautiful symphony. When a baby grows from a few cells to the beautiful ballet till up to puberty, this developmental time is just absolutely striking as to how that happens. And we want to get, ultimately, human technology, what BioViva is trying to do, what researchers are trying to do, is to get that ballet, that beautiful choreography, down to an art so that we can actually reverse that.
Yeah, so the point there being is that modulation is the key. So the knockout animal may not be the future that we want to project. But when you add some genes, you get benefits. So in the animal studies with the gene we're working with, there were benefits. There was actually decrease in the risk of diabetes type 2, things like insulin sensitivity increase. So that's fantastic. That's an aging disease. There's increase of muscle mass and strength, which is fantastic for frailty. And this is a gene that we can modulate in a sense relatively well by just turning on a certain percentage of the gene, right? If you want to think of it that way, dependent on the size of the therapy, I should say. But in the future, the goal would be to modulate your genes, to turn them up and down, and that's what will create actual precision medicine. It won't be like, let's just throw this in and turn it on. We can get away with it with the myostatin inhibitor because it's a gene that you naturally have anyway, and we can get away with it with a couple other gene therapies, but things like gene therapies that affect growth hormones, no. Things that affect other genes that we would need to modulate. Sometimes we want them to turn up, sometimes we want to turn down. And we just don't really have a succinct way of doing that right now, except for through things like mRNA therapies, where you could maybe several times a year come and take therapies that were very short acting, maybe 48 to 72 hours, and they would just give you the boost that you need. And so this is the type of platform that we are personally looking to develop outside of working with other parties.
Liz, in your gene therapy, you lengthened your telomeres. Can you speak on telomeres just for a bit, just define them, just because we in the previous episodes we haven't touched on it, and then also the results that you found since doing your gene therapy?
Yeah, sure. So the only cell type that were tested in my body, let's start with, are T lymphocytes. So that is very limited, and we hope to have companies expand on where we can look for telomeres in the future. But let's just talk about what telomeres are. So there's your chromosomes, and you have straight ones, and you have ones that look like X's. But regardless, as your cells divide, the ends of the telomeres get shorter and shorter. And this actually creates a disruption within the chromosome itself. It starts to sort of unpack the tightness, you could think of, and damage starts to occur to the DNA. So there's a lot of ways to die, and it's true that telomere shortening isn't the only one, but it's one that we definitely have to address. So I always, when people defend one part of aging, they really can't throw another part out. So as your cells divide, your telomeres get shorter and shorter. So we know that you're born with about 15,000 base pairs, conceived. You're conceived with about 15,000 base pairs, long caps at the ends of your chromosomes. And when you're born, you have about 10,000. And when you die, you have about 5,000 if you die of the diseases of aging, of old age. And we know that people who are born with short telomeres have a myriad of problems, a multitude of issues. And so we know that these play an important role in disease in general, not just in aging. So what we did is we looked at a lot of the products that were affecting telomere length or were suspected to turn on telomerase. And the only one that was strong enough, the only product out there that was strong enough to actually lengthen telomeres was the gene therapy. So this is so strongly correlated with a multitude of diseases that, for me, it really was my first choice. It was the most promising research that I had seen that could potentially not only help old people, but children as well. And so I had a hard time understanding when I got involved why we hadn't used this in a human. And when I looked around at how many people die every day of diseases that this could potentially affect directly, I was just really shocked. And this was probably the first time that I opened a website to check out exactly what bioethics were, because I thought that this must be the craziest document ever written. We allow people to die rather than giving them access to therapies that could help. And then we make companies like ours raise an exorbitant amount of money to just try to help people. And I think we've got this whole thing backwards. So anyway, I let the couple people in the company that I started with know that this would be the first technology that we'd move forward with. And since it had never been tried in a human, that I would try it. Since my life every day, I have reminders right here in my home of disease and how it affects my family and my child. I thought, well, this is the right way to go. I believe in this. We read the research. We took 2 years to catch up on everything that we could glean off of what we suspected would happen with this therapy. And we looked at the human cell data and all the animal data. And we just went, and, it was so funny because it seemed so obvious to me that this would be the right therapy to move forward with. I kept saying, I wonder if some other group is going to try it before we do, because who could read the research and not do it, So anyway, so I took that therapy and the myostatin inhibitor. We were pressed for getting our data together, getting my data together. We took pre-blood samples, we took pre-tissue samples, and we sent my one of the pre-blood containers overnight to SpectraCell, who is a company who does telomere length testing for the public and for medical doctors. And then about 6 to 8 months later, we sent another vial back. We had actually a time frame that we would send consecutively, but our scientific advisory board said you actually have to give these things time to work. So at about 6 or 8 months, we'd have to look that up. We sent it again, and the results were that the base pairs on the end of the chromosomes had increased by 600 base pairs. We know that they have a level of inaccuracy, but we used the same lab, and we had the same lab use the same technique, and that is a difference of 20 years. So if they're that inaccurate, I would say the test would be completely useless. So we are hoping that, in fact, that data is accurate, and we will continue to do more of those testings. But that was the information that we put out. We've also done a myriad of blood work, and we've just got new blood work back. Avi Roy has access to that. The biomarkers that have changed had either continued to improve or stay at that improved level, which is great because blood is a tough thing to work with. What happens is you tend to see all of these subtleties changing because, when is a good time? What is a good time of day to take your blood work? And what have you been doing for the last 3 weeks? Well, in my life, that varies massively because one time we'll do blood work in London, the next time I'll do it here at home. I might have jet lag, I might have spoke at a stressful meeting or, had some big event, and yet the blood work is spot on, continuous in the right direction. So one of the things was a six-fold improvement in C-reactive proteins. My fasting glucose levels in my blood glucose levels went down, and they have continued to stay down, which is probably the myostatin inhibitor. We just did a bunch of cancer screening, and this was, I feel fantastically healthy. It's been 1.5 years. We would think that by now we would have seen anything, and we didn't think that we would. But we just got that back, and that was raving review. It's actually below my risk for my age, well below.
Wow.
Yeah, so no cancer and below average risk. So these are fantastic things. And of course, with the MRIs, we saw increase in muscle mass and decrease in intramuscular fat. So, this is not curing aging in one fell swoop, but this is, this combination of these two gene therapies is more powerful than most drugs on the market, I would say, at this point.
Sign me up. You have increased insulin sensitivity. Is that correct as well?
Yeah.
Which is great considering type 1 diabetic in your household, right?
Yeah. Yeah. Well, the thing is you either have type 1 diabetes or you don't. But being a person who is getting older, I would be at risk of type 2 diabetes. Yeah. And even though, we think of your 40s as, well, when people are kind to me, they think of that, oh, that's not that old. I have a lot of friends with health problems already, I really do. And we've lost a few friends that were only in their 30s to things like cancer. And so when you talk about how early should a person intervene, I think what we need is data on these therapies as soon as possible through both the terminally ill and the pioneers, people who want to be part of a bigger cause, that want to go to battle with disease, who want to make a better world. We need to get that data, and the chances are that using these therapies in younger and younger bodies is where we'll have the best effect, where we'll actually be able to create preventative medicine rather than waiting for people to get sick.
Avi, aside from regulation, and Liz, we'll talk about that next coming up here so you can start thinking about it, but Avi, as a CTO, what are some of your biggest challenges that you're facing today?
To keep up with Liz's idea of how quickly future should happen.
Today?
Yeah.
The future is 1 second from now.
Yeah. I think like all visionaries, Liz has an idea about how the future should look like. The only difference is that it can be quite big, yes, but also unnerving. So when you're a company whose product is software, and you can go out there and you can say, it'll make the lives of so many people easier. When you're a company that's making a hardware product, you can say, it'll smooth all of these communication channels or these delivery systems or whatever. When you are a company that is working on bringing health and well-being to as many people as quickly as possible, then it becomes a life or death situation. So every day you are kind of under the gun, and we do this to ourselves, nobody else is doing it to us, to deliver the best treatment possible at the least expensive cost. And we get hundreds of emails from desperate parents to desperate friends to desperate grandchildren about their grandparents, and everyone in between. And so as a CTO, I don't think it's necessarily a technical problem that we are facing, that I am facing. It is more a challenge of convincing the stakeholders and I guess to an extent the implementation, people who are involved with the implementation, to be brave, to be bold, and to do this along with us as quickly as possible. And as effectively as possible for the patient. So it's more a call to arms, which Liz does so effectively, and to translate that in many languages, in many fields, and ask people to join with us in this journey and to do it as quickly as possible. The reason why I say the technical thing is not a problem is not because I'm underestimating the magnitude of the work that we have to do in the scientific area. We are very well aware of that. And as Liz said, that we are actually getting a little bit into research and development as well, and certainly encouraging our partners to conduct their own research and development. The reason why that doesn't bother me, or that challenge doesn't faze me very much, is because once we actually understand how important it is to do human experiments, as in to work in humans as quickly as possible, and if we can expedite that process, then it is just science. We already have a significant body of science that shows that we can increase the lifespan and the health span of mammals. And we just need to translate that science into humans. So I think what is holding us back is our inability to see the future as a brilliant place, the way Liz imagines it, and to be bold.
Yeah, I think the bold part is so important. I'm actually going to do a talk about this summer. When people say, well, what is the difference between the science happening today and happening in 100 years? And I always say the difference is you. It's your mindset, what you do, whether you petition your government, whether you invest in biotechnology, whether you get behind a cause, share social media. It all has to do with you. There is no technology that's going to come to the world that doesn't have you involved with it. Don't just sit and wait. Definitely, you need to get involved and you need to be part of it. A dear friend of ours who works with the company had, I think, the best analogy to what's happening right now. You know, it's synonymous to a starving population, a can of food, and having the can opener. So we've got people who are dying. We have the science. It's not perfect, but we've got it. We've got better science than ever before. We don't have small molecules with all these offshoots of non-targeted areas. We have therapies that we know what the genes do. It's precise, and we need to find out what happens in human bodies, and that's the can opener. And that's what we want to be, is we want to open that can and get the food to the starving people, or open that biotechnology and get access to humans. And this is, this isn't something that one person does by themselves. This is something that you create a team, and the world becomes the team. Everyone has a part in expediting access to therapeutics, and unfortunately, one day you're going to really need them. And Avi's right. We're contacted regularly, soberingly, by people who need access to medicine right now. And that probably leads into the complication of what you're going to ask me a question about, which is regulation.
No need to ask. Go ahead.
Okay. It's very difficult. It's something that we certainly could spend a whole podcast and maybe a whole 3 days talking about. And if you go to a conference or you're invited to speak with regulators, you'll find out that that is in fact the case. And after those 3 days, everyone will still be uncertain as to where to go with it. Regulatory laws are very complicated and convoluted. Some of the leading countries in the world have actually reached into other countries and regulate them. Okay, so it's not like in many cases you can't just go to a country and say, well, we're going to come in. They might be overseen by the FDA or at least the WHO, and then you have to look, that would be the World Health Organization, and you have to look to what these sort of regulatory authorities allow. And due to a lot of missteps in science and mostly risk aversion, we have a lot of clamping down on new technologies and what it actually takes to get a new technology through to humans. We were working with a group to get a grant early on when we first started the company, bright-eyed and bushy-tailed, and we wanted to use a gene therapy for Alzheimer's. And they told us, well, actually, even though there's some brain data that it might help, and there's animal data of some amount of safety, there's no data that proves that that gene therapy would help in Alzheimer's. Well, how do you get data if you can't use it? So I think that we tried to work with them for 6 months, and after 6 months, when I finally gave up, actually, I calculated how many people died of Alzheimer's in that amount of time and sent it to them. And just not to be rude, but just to be evident that, as I explained, without human data, we don't know. We've cured cancer in mice 100 times. We've cured Alzheimer's. We've affected heart disease. We've done amazing things in animal models, but that doesn't mean that they will ever translate to a human. And humans are dying, waiting for access to treatments now. So, when we talk about doing things the traditional way, I mean, this was just in a very small camp issue. We hadn't even hit the big regulators at that point. We have a very twisted system. I've talked to companies who have tried to do similar things in the U.S. Regulatory zone, and we're told to go back and do millions of dollars of research in animals. But that research doesn't really glean us that much information, quite honestly. We've cured a myriad of animals, and there are things like aspirin and penicillin that would have never made it through small animal studies. We wouldn't have them, and yet look what they have done for our lives. They've definitely, in the case of penicillin, increased our lifespan, and in the case of aspirin, kept us from suffering from pain, which is detrimental, and in some case, thinning the blood in a beneficial way.
Yeah, I'd be dead if it wasn't for penicillin. For antibiotics, I got MRSA, and man,
Oh,
I don't
wow.
suggest it.
No, I don't suggest it.
I had a
either.
hole in my chest, and you could see my rib cage. It wasn't the healthiest part of my life. But yeah, antibiotics saved it. So I'm really thankful for it. I think a lot of people misconstrue that you're trying to make people live forever. And I think everyone gets a really good sense now that you guys are out to really help people. And if you look at the website, BioViva-science.com, if you just type in BioViva, BioViva, it'll come right up. But you'll see on the website, if you do your own research, and I always urge people to do their own research, but there's a lot of stuff that you guys are looking at, and it's nothing like, we want to live forever. Yay! It's nothing like that. What you guys are trying to do is Alzheimer's. Let's find out something, anything to help out with Alzheimer's. And then let's look at, sarcopenia? The loss of
muscle wasting.
Yeah, muscle wasting, and then the plaque buildup that causes heart attacks, right? And that's I'm not even going to try and say that word. And then also Avi's realm, skin, or it's like skin aging, right? What they're just going to be. There's so many rich women there just getting their checkbooks out, telling their billionaire husbands, "You better write a check to them. Well, I want the best skin ever. Look at Liz's skin. Look at it. Jealous." Right? So you're going to get people that, but you guys are helping people is what I'm saying. Burn victims, Alzheimer's. I lost my grandma to Alzheimer's. So that's a personal one for me. But there's hundreds of people out there that you guys can help. And if you're starting to look into like muscular dystrophy rather, then you're even, it goes beyond that many people. And like you said, a lot of people are affected by aging. And you want to classify aging as a disease. That kind of scares people. Why do you think it scares people to do something so trivial like that?
Yeah, so let's go back. Yeah, of course, we want to affect the diseases of aging and the complex diseases. Why? Because they're driving mortality risks. And that's a really important point to get to. Of course, until we actually increase the lifespan of one human, I think that we should focus on health. Okay, so what does health do? Health may get you to that point, ultimately, of expanding lifespan. But if that's your initial goal, that's fine if you have really great science behind it. Some companies do, but we can't get there unless we affect health. So the idea is, let's get healthy people and let's see if we can expand lifespan. But that's not the focus, because until we've done it, it's really nothing to talk about. It's kind of science fiction. So let's do it first and then see where we go from there. But biological aging as a disease is I think one of the most important distinctions that we'll make within the next few years in many countries. And I'll tell you why, number one, that people get excited about it, and I'll tell you why it actually should happen and what we're getting wrong. It's always a problem with semantics. It's what do those words mean? How is aging a disease? Isn't aging a process? Well, actually, cancer is a process, so we can throw that one out. But isn't aging mean getting older by years? Well, absolutely. And how could that be a disease? Well, there's a couple parts of aging. So here's aging, and then let's pull it apart, and let's call this biological aging, and let's call this chronological aging. So we want you to get chronologically older. Yeah, we want you to go up in years, but biologically older sets us up for Alzheimer's, cancer, heart disease, kidney failure, and a myriad of things like frailty and the things that lead to our demise. So this is the process, this biological aging, that we want to halt and let you go on chronologically. What people get confused of is they say, well, my 12-year-old needs to get older. They need to get biologically older. But this is another mistake. So there's development, and then there's biological aging. Biological aging is actually happening to your cells after you're conceived. So some of the detriments, like let's say telomere attrition, the telomeres are getting shorter even when you're developing inside your mother's stomach. There's also damage that can happen to different genes during this time. Young people have been found to have atherosclerotic plaques, that word that you didn't want to say. Some young people are heading headlong into early stage heart disease, believe it or not. And believe it or not, even children get mutations that lead to things like cancer, like we talked about before. We don't want to affect development. So development and biological aging are separate things. So if you can separate biological aging from chronological aging, and then pull out biological aging from development and realize that this is something that sits on its own, it is a process, and it is the process that is creating the damage over time that leads us to the diagnoses. So why have we worked for so many years, 50 some years, trying to knock off some of the biggest diseases, and we've never found a cure? Well, that's because we were tackling symptoms. Wow. So cancer is a symptom, heart disease is a symptom, and Alzheimer's is a symptom of an old body. It's a symptom of cells not keeping up with cleaning up the damage anymore. It's telomere attrition, it's stem cell depletion, it's the buildup of glycation because of improper systems that no longer work. And so if we look at biological aging as the disease, we can eradicate all of those diseases of aging, probably in one fell swoop, although treating biological aging will not be one treatment, okay? So it'll be a multitude of treatments that tackle what we consider now the 10 hallmarks of aging. They keep expanding. Someone will find something new and they'll say, no, this mechanism isn't connected with that mechanism. But there's 10 hallmarks of aging, and actually Avi can tell you about those. And if we tackle them, we do create a cell that appears to be able to divide and its divisions and go through apoptosis, which means cell death, healthy for an unlimited amount of time.
Whoa. Okay.
So that would be the hope, and then that would be what would lead us into life extension. But right now it's how do we keep bodies healthy for a long time? And a lot of people don't like the biological aging as a disease because they think what we're trying to do is keep old people old longer. So we're just trying to expand lifespan, and now you'll be as if you are 90 for maybe another 50 years, and nobody wants to buy into that. But actually, Avi, could you talk about the hallmarks of aging, because I think that helps understand what's driving the force. So it is a matter of semantics. Not everybody likes the wording of biological aging is a disease, but actually it's very succinct, and it is the process driving the symptoms that we die of that distinctly on their own may not be what we think they are. So it's exciting.
Right. Do you want me to elaborate on the point that Liz was making, David?
Yeah.
About that, we have been able to take animals in the past 30 years and for the first time in human history, extend their lifespan. We have shown that lifespan and health are malleable. And people don't understand how big a deal that is, because that knocks out the argument that things are fixed, that lifespan is somehow fixed, that a bowhead whale has to live 250 years and a mouse cannot live more than, about a year in the wild. We can change that. Today, we cannot make a mouse live 250 years, but tomorrow we might. And in order to design anything like a steam engine or a rail car traveling across America, you have to understand the underlying parts. You have to understand how to put together that engineering. And that's what the hallmarks of aging are. What they are is the process by which we go from being a healthy young adult with tremendous biological potential to being a frail old person. Or in other words, the way we go from eating an entire 18-inch pizza and not gaining weight to not really eating very much but salad and having a middle-aged men's belly drift. So how do we go from that? What happened between those things? So the hallmarks of aging really kind of are the underlying principles that go wrong. And ultimately, we start looking like our 90-year-old selves rather than staying who we look like or felt like and the biological potential of our 25-year-old selves. And these are basically genomic instability, your nuclear DNA, all of the problems that happen with your nuclear DNA, your telomere attrition, which is the shortening of the telomeres that Liz talked about, the changes in your epigenetics that happens over time, the loss of protein function, protein that could be at the stage of the creation of the protein, or the use of the protein, or ultimately the recycling of the protein. So there are multiple layers of it. So one thing that people know about Alzheimer's is that you have these clumps of proteins that are not being recycled, and that's a problem in Alzheimer's, along with other problems that Alzheimer's has. Your cells don't talk to other cells very well as you get older, and this is called altered intercellular communication. And your cells don't listen to the beckoning of hormones from other cells, and this is called deregulated nutrient sensing. Your mitochondria that is within the cells seem to become more and more dysfunctional, especially in long-lived cells like your cardiomyocytes, like your heart cells, or your neuronal cells that have a very low turnover rate. And then, of course, senescent cells. These are cells that just linger, that neither die nor live, but don't divide. And they actually are detrimental to their surroundings. And finally, stem cell exhaustion. So there are tissues like your gut that replenish themselves, as in regenerate themselves every 24, 48 hours. And over time, they actually literally eat through the stem cell populations. That's just one example of that. So we have these 9 or 10 hallmarks of aging, depending on how you look at it, that are the core drivers of what is transforming you from a healthy young adult to a frail old person. And if we can, one by one, reverse many of these, bring them back to their youthful state, or clean them up, we think we can reverse biological aging in an already older person.
Well, you did it. You truthed me.
Well, yeah, that's actually something we stick pretty close to. It probably is a dirty word for most people. When you look at lifespan being malleable, you'll realize that in science we've extended the lifespan of worms by 11 times, and mice by 5 times, and a certain type of fish, a killifish, by 6 times. And all of these creatures were actually vigorous during that time. We created, or science created rather, healthy, viable life extension. So we haven't done it for humans, but we've done it for worms and fish and mice and flies. There again, proving that the Hitchhiker's Guide to the Galaxy was correct, that we are not the smartest species on the planet, because we are extending the life of other species, and somehow they have wiggled their way into gaining the massive benefits of science.
God, it's so frustrating to know that people are emailing you guys, mothers, fathers, just parents, was just asking, just looking for anything for help. And regulation is getting in the way, and there's things that help that you could extend life, or and I'm not just talking about parents with children, but it could just be grandparents too, just with aging, and we're letting people die because we're scared to kill them with something that's suggesting a positive result, and that to me is so frustrating. Yeah. How do you get over that and just keep plowing through? How do you just keep driving forward?
Well, if we knew that we could cure all disease right now, nothing would stop us. And actually, we do work on this every day. So what is the best thing to do when something's bothering you? You work on it every day. We work on it every day, and we are actually making some headway. So that's number one. Number two, we don't know, again, if we can cure all disease, but this is where you start. Where you start is you start the experiment. You start to see by using drugs in humans, these powerful technologies in humans, as to whether you can or not. When we have a child with a monogenic disease, there are some diseases that are more difficult to affect, like problems with mitochondria and in other realms. But if we have a monogenic disease, meaning we know what's wrong with one gene, the answer becomes much more clear. Depending on the gene, just replacing that gene is all they need. And generally what I do then is I will suggest that they talk to one of our scientific advisory board members who is well connected with the universities in the U.S. who are systematically demolishing monogenic disease. They can take a disease that have very few children who are affected or adults affected by it, if it's just one gene, and they can run a trial and really affect a multitude of the population that are affected by that one rare one gene defect. And so this is what we tell families who know that they have a child with a single gene mutation, is what it's called. We ask them to contact research institutions, research universities, and get their children enrolled or start to spearhead a program that will give their child access to that one gene, because it's a much simpler problem. But when we look at complex disease, we are just now at the forefront of our company's at the forefront of taking command to say we will take on the most difficult problem, that is complex disease. Much of that we can think of as the diseases of aging. You can also think of things like diabetes type 1, Crohn's disease, and a multitude of other complex disease like cancer that children have. And we can see what will work. Now, the cancer realm is a bit separated because I do believe that the best area for cancer patients is immunotherapy. But on the other hand, those are patients with cancer. The rest of the population that does not have cancer yet, and remember, 1/3 of the population will get cancer if you live long enough, that part of the population, if we treat patients with treatments that reverse biological aging, our hopes is that they won't get cancer. But outside of that, as far as cancer research, we leave that to the big boys, the companies that are working in immunotherapies right now, because we still are treating cancer. We are still treating the symptoms of cancer like most other diseases. In the future, again, hopefully these treatments that keep you from biologically aging will be the treatment for cancer before you get it.
Now, as we wrap up here, and I've got a couple of quick questions to wrap up for each of you, and we'll go back and forth so you guys both get turns at going first. But before, actually, let's just go into it. Let's ask these questions. But Avi, let's start with you. What is something that you recommend people research or read or find out more about?
Well, that's a very difficult question. If you ask one thing that they should do, I think then they should keep up with the BioViva blog, Facebook, Twitter, and all of those things. We don't just post, unlike other companies, things that our company is doing, or the conferences that Liz is attending, or the talks that have. If you go to BioViva's Facebook page or BioViva's Twitter, you will find that we post what is the coolest thing happening in biotechnology that week, that day, or around time. And it could be any number of companies that are doing it. We just love bringing health and well-being to people, whether it's us doing it or other companies doing it. That's kind of not really relevant. We are good at certain things, and then other people are good at many other things. So when you go to BioViva and our sister associated site, which Liz also launched for public dissemination of science, no advertising, nothing there, Longevity Reporter, it literally does those two things. Is that we work in cohesion with Longevity Reporter to bring the best health, biotech, and non-fake or non-junk news to as many people as possible. So we're not looking for silver bullets. We're looking for as scientifically accurate things as possible. And of course, things will fail, experiments will fail, and things like that. But we try to bring the best data that is available today to people, and the best upcoming science to people. And so I would highly recommend, if you're going to read just one thing or one source, that you go there. But there are hundreds of books that you can read, including Aubrey's book that he has written. And hopefully in the future, I can tell people to go and read Liz's book. So those are just a few sources. I hope that I answered your question accurately.
God, there's no wrong way to answer it. It's subjective, right? Liz, bring the podcast back, please.
Okay, so I think that like what people should get involved in and what they should immerse themselves in are three things. I think they should immerse themselves in health. I think they should immerse themselves in the environment, what's right outside our door, making sure they're doing the right thing. And the third thing, and the most important thing that I've learned on this journey, and probably actually throughout my life, is we need to treat each other a lot better. We need to stop going on the attack and learn to solve problems together. Being a woman in industry has taught me a lot about the ill behavior of people, and it really brings me back to that I'm a mother and I have a family first, and I've built a wealth of friendships, and those are more important than any amount of money in the world. So health, your environment, and your friendships, these are all really important things, and they all drive each other. So we want you to learn about your biology. We want you to learn about the things out there. We want you to learn about the techniques in science. We want you to learn that we're not talking about science fiction, that this is science fact. We have reversed aging in animals. It is time to create a world where people don't die of Alzheimer's, even if you don't know if you want to live for 200 years. Why should we talk about that until we actually have the first person who's done that? But when we live longer, we're going to need to ensure that this planet is in good shape. And actually what good science does is makes it so outdoors is just as healthy and vibrant as has all the important aspects of things that create an atmosphere, which actually must seem like a miracle to people that, when you look at so many planets that we're looking at going to, all of the intricacies of the things that create an atmosphere are all of the things that have to do with the health of our planet. And good technology will allow us to escalate, have all the things we want, but won't affect that outdoors. And that's one of the things that I do like about gene therapy is the runoff and the pollutants are a lot less than some of the drug manufacturing things that we do. And then again, socially coming together and giving us a reason to want to live longer. We need to learn to work together. We need to learn to give a compliment. That's like flexing a muscle. It's like picking up the weights. For the way society has run us, it's easier to insult somebody than to actually say, you're doing a good job. How can I work with you? What can we do together? What can we achieve? And even if I don't want to work with you, just giving you a compliment, we're working away from that. The idea is that the many should have it good and not the one. And so those are the three areas. And I know that that's really broad. For science, I definitely would go to the longevity reporter. For the environment, I don't know, probably
anything
there are
Leonardo
several
DiCaprio's doing.
Yeah, maybe. I don't know, because I don't watch much of the social media, but maybe if he's on the environment, then see where he's looking. There's like the Sierra Club and other things that are trying to preserve land. I don't know if you have to look in to see if their ideas are good. I'm focused on the one area. I can only do one thing at a time. But the third thing you can do yourself, treat people with dignity. If you want to live a long time, you want to be in a world where people live a long time, we better get along.
Yeah. All right, Liz, it's your time to go first. And the question, I have like 3 more questions that I have to battle. Just stick to one. This will be the last one, and then we'll wrap up. So, Liz, you type in google.com for the day, and there's a Google Doodle, there's a search bar, and below would be a place for a banner. And you can populate that banner with anything that you want for 24 hours. Arguably, it'd be the largest billboard in the world for 24 hours. What would you put on that billboard that's non-commercial?
Oh, wow. What would I put on that billboard that's non-commercial?
He's laughing so hard right now. He's like, I got an easy one.
Does it have to be an image?
It's whatever you want. It could be a GIF. It could be
okay. Well, if it was an image, I think it would be a combination of the 3 things I just said. I think that it would be like a tree spiraling into a genome, spiraling into a really happy face.
That sounds like an awesome tattoo.
Yeah, I probably should get that on my back. I think there's a saying about girls that do that.
Do it. Okay, Avi, what would you put on?
Well, actually, I'm glad that you gave me more the second question, the second turn of the second question. It is more difficult, but I had 30 seconds to think about it, and it would be a banner a little picture to with a link to learn more. And Liz launched the nonprofit project, the Longevity Reporter, purely for education. And the thing that I have told you today, which is how we have extended the life of worms, flies, and mice, not just extended their life, but health span, and they are collectively called the Methuselah organisms. I find that most people don't know about. And so I would we have a slide in our slide deck that shows those three, and I would put a question mark next to humans, and just say learn more, as in how could we make humans the next subject or the treatment for humans to have them extend their lifespan 11, 5, or 10 times, whatever it is.
People are going to think it's a clickbait of sorts, and maybe not click.
Yeah, it is. That's the way we do it in our slide is that we have the link to the studies. I have to say, David, the funny thing is that anytime you give a talk about aging, people will turn off sometimes, and they think this is the same trope. So people in literature or in magazine articles or everywhere where they'll say humans have been seeking for longevity and this elusive immortality since the time of Gilgamesh, if they're learned. If they're not, they'll come to Greek analogies, or they'll come even closer to the Faustian bargain in Cambridge in the 14th century.
Or they'll just talk about snake oil salesmen in early American history.
Yeah, those analogies are always used. Whereas that is completely inaccurate, because for the first time in history, in the last 30 years, we have been able to show the lifespan is malleable. And this message really has to get out and sink into the populace, that the tropes that are used by science fiction and by authors who have not read what we have been doing in the field for the last 30 years, and Nobel Prizes have been awarded for this research already, it hasn't actually sunk in the public consciousness that we can take a wild animal and completely make its lifespan malleable. This has never been done in human history. We have dreamt about doing this, but we can do it now. And if people actually understood and it sunk in this into the public consciousness, well, then tomorrow will be very different.
I'm on board. I like it. That was a good answer.
Yeah.
I got really wrapped up into it, and I forgot I was doing my job.
Yeah, mine was dumb. Oh.
I don't think there's a right way or wrong way to answer that question. Avi, I'm going to
I think with more time, we would really, all three of us could come up with the ultimate. But like in, a few seconds, it really is difficult. Like, how do you touch people, and how do you convey that we can do better, and how can you convey that, this technology, okay, let's just make it very, very, very clear so that everyone understands it, because everyone can agree with this. We will cure biological aging. It is happening in animal models. It has already happened in some species. To an extent, we can do better. We are already doing it. We will do this. Will it happen in your lifetime, or will it happen in your children's or your grandchildren's lifetime? That's the only difference. And the difference between it happening now and then is you. That's it. That's the difference. It's you. It's you getting involved in ensuring that it happens. Okay? That's the truth. We will do it. We will absolutely do it. But whether we do it today or we do it in 100 years is up to you.
That's beautiful. One more question, because I want to make it fair again for Avi. Avi, what's your favorite purchase that you made the last year under $1,000?
Oh, that's a really random question. A plane ticket.
Oh, a plane ticket?
Yeah.
And
brought
you the most joy?
DNA. Well, no. You see these DNA strands and the painting behind me and stuff?
Yeah.
So my partner doesn't live here. So hanging out with my partner, I think buying the plane ticket is probably the best purchase that I did.
Oh, okay. Well, that's a sweetheart move.
Well,
Jesus. I'm sorry I asked this question. Liz, you're screwed either way. Like, he just out-sweethearted you, unless you could do that. Your favorite purchase under $1,000?
Gosh. I don't really find spending money synonymous with happiness. So I have to think about that for a minute. But I could probably say that it was buying lunch for some of the favorite people that I work with and are my friends. I mean, every time I get to sit down with people and, spend some money so everyone can have a nice meal and not be concerned about that, and a few drinks is probably some of the happiest things that I can do. I don't know that I'm the right person for that question. So I think of the situation more than the spending of the money. I mean, like when we talk about money with BioViva, we're talking about we need big loads of money and that gets jobs done. But when you talk about personal life, I actually don't really need that much.
And the reason for my asking you that question is because it hints towards people that are either egotistical, materialistic, or altruistic in nature. And that's the main reason why I asked that question. And I only reveal that after, because some people.
Oh, wow. I don't know how I did then.
You did great.
But Avi's answer was like,
I'll buy people lunch. That's what I'm doing. And so it's totally different. Then that's the reason why I asked. And that's the reason I asked for the way that I did. So I want to thank you both. I actually had a really good time. Time escaped me again. I have too much fun doing this. You guys are fascinating. You guys are so well at explaining something that's very complex and making it simple for a simpleton like me to understand. And as far as our audience is concerned, I'm on the lowest percentile of understanding, comprehending these advanced tactics.
Remember, you are the product of millions of years of evolution. You're an amazing person. You are a succession.
That's subjective.
No, it's very difficult. Billions of years, a succession of successful readings. Do not ever put yourself down. Every one of us is amazing. Every one of us holds the seed of an idea that could change the world. And so just remember how complicated life was to get to you.
Thank you. I appreciate that. The main reason, and it's been brought up, like, why does he talk so much shit about himself? The main reason I do that is because I constantly tell myself I'm average so I can work extra hard to be the best at what I do. And so if I constantly remind myself that I'm simpleton, I'm not that great, then it pushes me because I'm competitive to be the best at it. So now we can drop it and everyone can be like, oh, okay, that's why he talks shit about himself. So
yeah, but just don't listen.
Yeah, I won't. It's just, yeah. It's like when I'm holding a yoga pose and I'm like, what are you doing? You're like way older than me. Why am I so inflexible? I just get competitive just in nature. Sweet. Yeah.
I want a gene therapy for flexibility. That I do. I will be selfish about that. I would like to be very flexible. I see people who are in gymnastics and who are very good athletes. And this is the body at its most beautiful.
Yeah.
These people are I think the most beautiful, humans on the planet. When the body is capable of doing all of those things and is strong, and to me that is the epitome of beauty. And of course everybody would like to be capable of bending backwards. And I just watched something recently where a woman bends backwards, almost bends herself in half, and she did this it's a series of holes and ladders she had to go through and squeeze through tiny spaces by contorting her body. And I just thought that was the coolest capability ever. We should aspire. We should all aspire.
Do it. Go to yoga. I go weekly. Helps my back out a lot. And I think it really does help with meditation and also with just stretching and helping your body out. It's my anti-aging. It's a cheap way of doing it. How about that?
Meditation is awesome.
Liz, thank you so much. I appreciate your time. I know that you're super busy, and I really appreciate it. And Avi, it was a pleasure having you on, or Dr. Roy, a pleasure having you on. I sincerely appreciate your input and just the work that you're doing. Your job is something that not very many people can do, and it's something that I would never want to do because I would get fired in an hour. But you're doing it. You're doing great things, and I'm so excited to see what BioViva is going to come out with in the future. So if someone wants to find out what's the new, what's the latest and greatest, besides going to Cybrink, because we're going to publish whatever the hell you guys are doing, and making sure, cybrink.com has whatever you guys are doing that is super exciting. Where can people find, reach you guys, shout you guys out? What's the best way?
I think the website, I think Avi would agree. You can go to info@bioviva-science.com, and that's the best way to find us. And thank you for doing this podcast. Obviously, getting the word out is one of the most important things to do, is to actually rally the troops and get people interested and get people excited.
Avi, anything else to add?
Well, no, I mean, I would agree with Liz. BioViva-science.com is where you go. Info@bioviva-science.com is how you would connect with us if you want to send us an email. There's on our site, there's a way to send us an email. If you don't want to email it to info, you can connect with us on Twitter and on Facebook. And we have presence everywhere. So absolutely, you can connect with us any which way you like.
What you guys
and come and see us do a talk. Come and see Avi talk. Come see me talk. Robert Powell's, who's part of BioViva, also does talks. And this is come and meet us and get.
I'm down.
Have fun.
I'm down. I'll buy a plane ticket. It won't be as romantic or sweethearty like Avi because he ruined it for everyone. But I'd still go to a conference.
You asked.
I know, but I didn't know you're going to blow it out of the park with the best answer ever. Like, plane ticket? What the hell is he talking about? Oh, yeah. Well, okay. Now I feel like an asshole. Like, that's a sweetheart move. Anyway, we could do this all day. Thank you guys so much. Have a great day. Thank you.
You too.
Have a great day. Bye.